The reason we study the names for these different pairs of angles is because these names signify a relationship. And the better that we understand the relationship between pairs of angles, the better we can work with them and make sense of the geometric problems and situations we encounter. All right, let's go over a few more terms. Okay. Two adjacent angles are a linear pair when their non-common sides are opposite rays. The angles in a linear pair are supplementary angles. So two adjacent angles are a linear pair when their non-common sides are opposite rays. Okay? So if we see this figure over here, we have two adjacent angles. Angles 1 and 2 are adjacent to each other. They got a common vertex and a common side. And their non-common sides here are opposite rays of each other. Okay? Two rays going in the opposite direction, okay? And actually forming a straight line. And we would say that these two angles are supplementary. So if you have two angles forming a linear pair, two adjacent angles forming a linear pair, then those two angles are supplementary to each other. We also have a term where we say two angles are vertical angles when their sides form two pairs of opposite rays. So two angles are vertical angles when their sides form two pairs of opposite rays. Again, if we look at the figure here, angles 3 and 6 are vertical because their sides, here and here, and then here and here, form two pairs of opposite rays. Opposite rays right here, and opposite rays right there. Okay? And we could say the same thing for 4 and 5. Okay? Their sides are forming opposite rays. Let's look at a couple of examples where we can use this knowledge. Okay. So number 5 says, identify all the linear pairs and all the vertical angles that we can see in this figure off to the right. All right, let's start with the linear pairs. Let's name the linear pairs. So for linear pairs, we're looking for where do we have two adjacent angles that their non-common sides form opposite rays. Okay? And remember, we're talking about pairs, so it's going to be two of them. So like, I'm not going to say that 1, 2, and 3 here are forming a linear pair. But I could say that angles 1 and 4 are forming a linear pair because they have these non-common sides as opposite rays. Okay, they're adjacent to each other. Okay, 1 and 4 are adjacent to each other, common vertex, common side. And their non-common sides are forming opposite rays. So angle 1 and angle 4 are forming a linear pair. We also notice that we can see the same thing in angles 4 and 5. Angles 4 and 5 are adjacent to each other, common vertex, common side, and their non-common sides are forming an opposite rays. So angle 4 and angle 5 are also forming a linear pair. Right, then we can talk about vertical angles. So vertical angles would be two angles that their sides are forming two pairs of opposite rays. So we can see in this figure that, we can see in this figure here, and you want to be careful because sometimes it can be hard to tell. So like, if you use the figure above to help you, it's a little bit easier where it talks about vertical angles. But if I'm looking at 2 here and then 4, okay, those aren't perfectly forming opposite rays, okay, right there. And so they may be like across from each other like what we saw in the picture above, but that doesn't make them vertical angles. But if I look at 1 and 5, okay, if I look at 1 and 5, their sides are forming opposite rays, okay? One pair of opposite rays right there, and then opposite rays right here. And so we would say that angle 1 and angle 5 are vertical angles. Okay? You'll get used to identifying the shape pretty easily, or the figures pretty easily when you see, oh, those are vertical angles or those aren't. But just make sure that you're looking for, are they actually forming opposite rays in their sides. All right, let's do one last example. 2 angles form a linear pair. The measure of one angle is 5 times the measure of the other angle. Find the measure of each angle. Now the first thing I notice in this problem is that I don't have a figure. And it's usually helpful to have a figure to go off of. So I'm going to draw one. So I know that I have 2 angles forming a linear pair. The other information I know is that the measure of one of the angles is 5 times the measure of the other angle. So whatever the measurement of one of the angles is, so let's just call that x degrees, right? If we don't know what the measurement of that angle is, we're just going to call it x, okay, because we don't know what it is. The measurement of whatever that angle is, the other one is 5 times that amount. Okay? So I'm going to take 5 times x. So one angle has a measurement of x degrees, the other one has a measure of 5 times x degrees, and we want to find the measure of each of those angles. So how would we go about this? Well, we look at what's the information that's given to us. We know that these angles form a linear pair. What do we know about angles that form a linear pair? We know that they're supplementary to each other. Okay? What do we know about supplementary angles? Their measurements add up to 180 degrees. Okay? You see kind of how that line of logic kind of helps us to solve this problem. We have a linear pair, which means they're supplementary, which means their measurements add up to 180 degrees. I'm going to simplify and solve for x. 6x is equal to 180. Divide by 6. X is equal to 30. So we found x to be 30, and remember, what was x? X was our smaller angle. Okay? So we just found one of our angles, and that's 30 degrees. And now what's the measurement of the other angle? Well, we said that other angle was 5 times that amount. So I'll take 5 times 30, that's 150. So in this figure with this linear pair, one angle should be 30 degrees and the other angle should be 150 degrees. And again, I can tell that I was pretty much on the right track because 30 plus 150 is 180. This brings us to the end of our first unit. In this unit, we've covered much of the basics of geometry that we will need going forward. From naming figures, to finding distance, to identifying angles. You will see all of this again in later units. So don't be afraid to come back to these lessons and these notes for a good review.